Examples here in terms of finding the derivatives of using possibly product rule and quotient rule. Starting here with number 1, well, we have just a regular polynomial, so we don't need to do anything special here, just our basic power rule derivative. Bring the power down in front, 4 times 3 gives you 12, and you lower the exponent by 1, so 12x cubed. This guy, same idea, 12 times 2 is 24, lower the exponent by 1. In this one, when it's just an x, we look just at the coefficient, so plus 2, and there's your derivative. Looking at number 2, in this case, we have two things being multiplied by each other. So I have to do the product rule here. Product rule is 1d2 plus 2d1, first times derivative of the second, plus second times derivative of the first. So 1d2, there's your first. Here's your derivative of the second. Derivative of sine of x is cosine of x, plus the second, which is sine of x, times the derivative of the first, which is 3x squared. At this point, trying to simplify, really the only simplifying I can do is maybe to bring this coefficient out in front. Just the standard form would be to put the polynomial in front of the trig function. So this first one I'm going to write just as it was, x cubed times cosine x, and then I'm just going to make it 3x squared in front times sine of x for my second answer. All right, number 3, also a product rule, sine times cosine. So here's your first and your second. So we have h prime of x will equal the first times the derivative of the second. Derivative of cosine is negative sine, plus the second, which is cosine, times the derivative of the first. Derivative of sine is cosine. So to simplify this, what I'm going to look at here is I have sine times sine, which would be sine squared of x. Now it was negative here, so I should have a negative as my answer there. And then cosine times cosine would be cosine squared of x. That's a perfectly good answer. Just if you were looking at a multiple choice answer, it would probably be cosine squared of x minus sine squared of x. Doesn't matter the order, just make sure the signs go with the right part. The minus with the minus, the plus with the plus. Okay, looking now at number 4 here. Now we have a fraction. We have a division problem, so I should be using the quotient rule. Remember, the quotient rule, low d high minus high d low, all over low squared, you know. So, again, low times d high, derivative of the top, 2x, minus the high, which is x squared, times d low, derivative of the bottom is just 1, all over low squared. So x minus 4, that quantity squared. And we'll leave that denominator in that factored form. That's the safe way to go. We do want to try to simplify the top, though. I'll do that by distributing through. I should get 2x squared minus 8x. And then x squared times 1 is just x squared. Make sure you keep that minus there. So minus x squared. Again, all over, just the exact same on the bottom. I have 2x squared and a minus x squared. I have some like terms I can combine. So if I have 2x squared and I take away an x squared, that just leaves 1x squared on top. Still have the minus 8x, and again, I'll leave the bottom just as it is. This will be my final answer. And really, I should be boxing all of my final answers here. It's just good common practice in general, but definitely for the AP test as well. They like knowing exactly what to be looking for your answer here on these. So getting to that little common practice here would not be a bad idea. All right, so let's see what we have next. Number 5, we have another quotient rule possibility here. We have a fraction, so think quotient rule. So we have k prime of x will be, again, low d high minus high d low, all over low squared. Low times d high, derivative of the top will be 2x minus 4, minus high d low. The high is x squared minus 4x. D low, derivative of the bottom is just 1. All over low squared, x squared. Again, simplify if we can, which we definitely can. I'll just distribute here. I will get 2x squared minus 4x for the first part. This one here, when I multiply by 1, it stays the same. I got to remember this minus, though, and really distribute the minus. So it'll be minus x squared plus 4x all over x squared. Well, I have 2x squared minus an x squared. That leaves me with just x squared on the top. And then with the minus 4x and plus 4x, will cancel each other out. So I have x squared over x squared, which equals just 1. So that was actually really easy. Actually, here's another reason why. if we would look at the same problem right from the beginning, I could have rewritten this function right from the beginning as k of x equals, what I can do here, because I have an x everywhere in the numerator and denominator, I can take out an x everywhere. And that would just leave me with x minus 4 over 1. Well, I can take that derivative very easily. That's just regular power rule. And the derivative of this is just 1. The derivative of negative 4 is 0. So there's your answer just like that. So if you can simplify first, do it, because that'll make your life a lot easier than having to do your big quotient rule or product rule or whatever, and having to go through that route. So in number 6, you might say, how can this be product or quotient rule, because it's just, a trig function? Well, I can rewrite this guy as, we said, sine of x over cosine of x. Now I can actually take a derivative. I can say that y prime of x using the quotient rule is low d high, so here's the low, cosine of x, d high, derivative of sine is cosine, minus high d low, so minus sine of x times d low, derivative of sine, or derivative of cosine is negative sine of x. All over low squared, cosine of x, that whole thing, squared. When I simplify this, cosine times cosine is cosine squared. Sine times sine is sine squared. I have a negative times a negative, so it's a positive sine squared of x. And then on the bottom here, cosine of x squared, that is just cosine squared of x, same thing. To simplify this, we learned in trigonometry that sine squared plus cosine squared is a trig identity, and it always equals 1. So I have 1 over cosine squared of x. Then my last thing that I can do, 1 over cosine is a reciprocal. It's the reciprocal of secant. So my answer is secant squared of x. So this is something you should always know. The derivative of tangent is secant squared. But if you ever forget it, or you just, have one of those moments where, oops, I don't remember, you can always go back and figure it out using the quotient rule.